Welcome in, folks. Thanks for joining me today. Life is hard, so let's ignore it for a while. Today, I want to tackle one thing that still is bothering me about our baseball universe. And I actually, full disclosure, I went off and I recorded a video for what I'm about to do. And it was over an hour and I struggled with something. There was just, it took a long time to debug an issue. And at the end of it, I realized it's not even what I really wanted in the first place. So today we're going to build off of what I did off camera, and we're going to just tweak it slightly so that we get the results I want. So here we go. What is the inspiration? What's the problem we're trying to solve? This is the problem we're trying to solve. We are going to have 4 leagues of 16 teams each. And when I create a league, here's 16 teams, I can choose, whichever region I want. I want the complete solar system. I want the whole solar system to be involved in every tier. So this is one tier, and you can see if I randomize the cities, most of these cities are being pulled from either Venus or Ganymede. Just because of the way things work, there's just way more cities on Venus and Ganymede than any other planetary body in our solar system. So I would like to see this more representative of the solar system in general. I want to see other countries in here. And one thing that I don't like about Out of the Park, say for instance, here's a Ganymede. I can change this. So take a look at Base Marius Regio. That is the city name. If I change this to a different country, the city name doesn't change. So I can't come in here and select different countries. I would have to change the city names manually as well. And that's kind of dumb. Plus the abbreviation. So if I change the abbreviation and, let's say Winnipeg, the abbreviation is not going to change either. So none of this changes. What I want is a way of getting good representation across the solar system. Basically, I don't want 7 teams in a tier from Venus. That's not what I want. So, and I also discovered that Out of the Park it's got great export options, but it does not have very good import options. I guess the developers decided that their database schemas were too fragile to let people like me mess around with them. So all we can do is export information. So to import, what I'm going to have to do is I'm going to have to pre-generate lists of cities and their countries with following certain rules that I want, and then manually enter those in as we go along. So that's what we're going to have to do. So we can actually just minimize this. I'll show you what I want. So this is what I had written up before my last video that I scrapped and you won't ever see. But this is essentially what I was going for. We want all planetary systems represented across all 4 tiers. So this was my algorithm. For each tier, I was going to take 1 team from every planetary system. Just take the largest city in the planetary system And so that would be 10, because there's 10 planetary systems. Remember, the asteroid belt is a planetary system. That would be 10 out of 16, and then I was just going to take the next 6 largest cities that were, unclaimed. And I would output a text file that contains all the 4 tiers: city, the system, the country, and the country abbreviation. Remember, the country abbreviation is important because this dictates what the flag of the country is. So that's we got to include that. And so this was going to be a text file that I was going to follow. Okay, now, next piece of information. We did this. And this is what it came. This is what I got. So we got the 10, from each. So we got Venus, Jupiter, Mars, Pluto. We got the moon here. All the different systems. And then we chose the next 6 biggest, and what do you know? They're all just from Venus. The next 6 biggest, we've got 2 Venuses and 4 Ganymedes. This is it's all just Ganymede. But by the time you get to tier 3, you do have 1 Europa, and tier 4 has a Mars. But that's not what I want. I don't want that. So we're going to tweak my code and fix that. And I think what we're going to do instead, so this is the code I wrote last time. Basically, we just make, whoops, okay, that's fine. Basically, we take all the cities, we order them by population. And this was me doing some debugging. Yes, sometimes debugging by sending logs to the console works. Sometimes it does. And then I took all the cities by planetary system and I made a dictionary so we can look up, Venus. The Venus key has all the cities in Venus ordered by population. So that was helpful. All right, and then we created a city data record, which just has our columns that we want. So that's all we care about. And yeah, so the way we did this, we picked 1 team from each system. And that works. But then we take the next 6 biggest teams, and this I don't like. I really don't like this. So what I'm going to do is I'm going to pull this out into its own, just a function here. So we're going to make a function, and we're going to say, actually this is in my main program. Oh well. Yeah, we'll just keep it a regular function. Nah, you know what? It's okay. We can make this an inner function. Okay. What we're going to do is we're going to basically pick a city data. So we're going to pick a city data and get next. And this is going to be Boolean random system. Okay, so this is going to be how we do this. We're going to take we're going to take this. So here, first of all, no, we should first do this. Let me bring this up here. So first we want to say if no, you know what, this no. String planetary system. Okay, this is what we want. So given the planetary system, just get me the next city that's going to be it. So first we're going to say the dictionary is data by system. Okay. So we're going to say our team equals data by system, planetary system. And so this gives me access to the list of cities. And then I'm going to take the first one. Remember, not remember, because we did that last time, which I'm not going to show you. I've done this order by descending on population everywhere. So the biggest cities are going to be at the top, and the smallest cities are going to be at the bottom. Okay, so we just take the first one from that system. So that's the team. And now I'm going to add that. Is okay, looks like I'm going to have to take a teams list in here. Okay. We'll say current teams. Okay, so current teams dot add. We're going to add the team to it. And now what's important is we're going to say data by system. Planetary system, and then we're going to remove the team from it, because once a city is already used for a team, we don't want to use it again. So that's all we're doing. Oops. Okay, and then that's essentially it. You might be asking, why are we passing in teams? You would be correct, because I don't know what I was thinking of. We don't need to do that. There we go, and then we'll just return team. Okay, so we're just grabbing it from the top, and we're giving it back. So all of this was how we picked it. Now, instead of, well, I guess, yeah, we can still do this. Instead of each, we're going to just add teams.add get next from the system. There we go. And then we don't have to do this. We don't have to do this. And then we can do that. Okay, so teams just gets one from each system. Now, what I want to do, instead of picking the next 6 biggest, we still need 6 teams, right? So we're gonna do this int i0, I is less than 6, I plus plus. Okay, we're gonna take 6 random systems. Okay, so random index equals, do I have a random? I do. Random.next. And I think we're going to do data by system dot count. Now, data by system is a dictionary, and a dictionary is by definition. There we go. A dictionary by definition is just an IEnumerable of a grouping of string and city data. So how many groupings are there? There's one for each entry in the dictionary. So this will give me the next random grouping. And then we will go teams.add. What did I just do? Man, I've been doing that so often lately. It must be a shortcut somewhere. Teams.add, and now we're going to say, what are we going to say? Get next. Data by system. And this time we're going to, now, can I do element at? Yeah, element at random index. Dot key. Okay, that's going to be the system name. Now the other thing, returns a non-negative random integer that is less than the specified maximum. Can next produce 0? The range of return values ordinarily includes 0 but not max value. However, if max value equals 0, 0 is returned. So 0 can be selected. Okay, so that's it. So we could get a few more Venuses, but this is 6 random Venuses. And so we're going to do this, we're going to generate it, and we're going to see if we can, we're going to have to make sure that now the planetary system 0 is Mercury. So in our team cities, these last 6, if they don't have any Venuses in, any Mercuries in them at all for all 4 tiers, something fishy's going on. Because I think we should get at least 1 Mercury. So I do want to make sure we're not forgetting about Mercury. But this file should become a lot less Venus heavy. And we just got to give it a minute because this laptop is old. There we go. This looks a lot nicer. Look at this. We have Mercury. There we go. There, right away. We got a Mercury. So 0 is definitely a valid random value there. So Mercury, asteroid belt, Jupiter, Uranus. So we've got, there we go. We've got Mare Serenitatis here on the moon, and we've got Montes Rook. So we got 2 cities on the moon in tier 1. So that's cool. Here we got a couple of Titans, because Saturn was chosen twice. That's kind of the whole point of randomness. So that's fantastic. I really like that. One thing that I noticed last time, which I will just point out this time, since I'm not sharing that video, these cities are massive. This is not 5.7 million. This is actually 57 million. So these populations are huge. Now, much like actions in like a tabletop RPG or something like that, I've decided that I'm okay with that. That's just what happened. That's what the algorithm spit out. We do have small ones. Look at this. This Larissa on Neptune is only 144,000 people. And I've just decided that is the nature of the solar system in the year 3000. Cities are huge. Some of them anyway. Yeah, so now this is going to be used to transfer, and let's just see if this is a valid thing to do. So I'm going to move this off screen right now, and I'll pull up out of the park. So what I would do is I'd look at my tier 1 here, and I'd say, okay, now you can't see this because it's off screen, but I can say, all right, this is Fort Aphrodite Terra. So I would do that. I would come up with an actual abbreviation that makes sense. Maybe FA. And then I would choose Venus. I would choose Venus from the drop down. And then I would come here and I would say, okay, Cor Missia Solsi. I don't know what that is. And we'd call this CS. And then I would choose Ganymede, because of course I'm choosing Ganymede. I don't know what this line is. I suspect these are the quality 5 planets, but yeah. And then I would come here and I would say, okay, so the next one is Sector Arabia Terra on Mars, and so on and so forth. My 2 examples are the 2 I've been trying to get away from. Okay, so let's do one from this one. So okay, so this is Uranus. This is Cor Messina Casmata. Good, I can paste there. That's good. So I can say CM, and then this would be Titania. TIA, that's important to know, because that is probably Titan, but I'm looking for TIA for Titania. So this is going to be really cumbersome, and I won't bore you with the details, and this right here is just the test. So that's it. That's what we did. We did it. So good. So once again, here's our teams, and we're going to run this, and every time we run this, this is going to generate new values. It's going to generally take the same, like, top cities, especially in tier 1, but you'll notice this time we've got something that's only 33 million people, because in our city generator, when we create the population of a city, make this better. I forgot about that. But oh yeah, that was when I was actually making the city names, but now we're using features for the city names. We don't need it. So this is the create population of the city, and I do some math, and I send it, and I throw it into a Gaussian distribution, just to give some randomness to it. So the populations aren't always going to be the same, but also the flags get regenerated every time. So what's Venus's flag in this iteration? There you go. There's Venus's flag. But the next time we run it, Venus will have a different flag. So there will come a definitive time when I run this program for real to calculate all of our actual values. And then we can start, which I think is, yeah, kind of next time. Next time we'll run this and we'll start creating our leagues. So that's exciting. Okay, anyway, here we go. So thanks for joining me. Have a great day, and we'll see you next time.